Hello students, this video is a continuation of gravitation chapter. In this video we will discuss about the free fall and acceleration due to gravity mainly. These two topics we will discuss in this video. First of all, free fall. When a body falling from a certain height under the influence of gravitational force only, that is said to be free fall. If a body falls from a certain height, suppose, only under the influence of gravitational force is acting on it. Due to gravitational force of Earth, is acting on it, due to that the body is falling. So due to the gravitational force of Earth, if a body is fall from a certain height, if there is no external forces acting on it, then that is said to be free fall. And if you believe that if you throw two objects having a different mass, suppose a leaf and a stone falls from the same height, you will see that both will reach the ground at the same time. Is it? But in practical, leaf and stone will not fall the ground at the same time. That is because of the air friction is there, air resistance is there. But if you throw the two objects from the same height in vacuum, you will see that both the hit the ground at the same time. Because when it is falling, the gravitational force is acting on it, and due to that gravitational force, there is an acceleration produced in that body, and that is said to be acceleration due to gravity. When a body is freely falling from a certain height, the acceleration produced in the body is said to be acceleration due to gravity, and that acceleration, that is denoted by small g, that is said to be acceleration due to gravity. And this acceleration does not depend on the mass of the object. In generally, more the mass of the body, less the acceleration. When the body moves horizontally, if the body is moved horizontally, more the mass, less the acceleration. But when a body falls from a certain height, the acceleration produced in the body does not depend upon the mass. And as a result of that, both the object, still they have the different mass, but they will hit the ground at the same time, if they fall in the vacuum. But in general cases, due to air resistance, air frictions, there is another. So due to that, it may be the leaf will blow up, stone will fall down. But अगर आप वैक्यूम में दोनों को गिराइए, आप देखिएगा दोनों ग्राउंड में सेम टाइम पे at the same moment both will be the hit the ground. So that is so there are the two things here. Free fall means when a body falling under the influence of gravitational forces on it. Means if there is no external force acting, that is said to be free fall. And during free fall, जो body में जो acceleration होता है, उसी को acceleration due to gravity. The acceleration produced during a free fall of a body is said to be acceleration due to gravity. Now here are the two important questions. One is that derive acceleration due to gravity, or in other words, it is also may ask you so that acceleration due to gravity does not depend upon mass of the object. So both questions have the same answer. We have to simply derive acceleration due to gravity. So now we will discuss the derivation of acceleration due to gravity. That is acceleration due to gravity, means gravitational force of Earth के चलते, and it is denoted by your small g. In this chapter there is a 2g. In earlier video we have discussed that the capital G, that is universal gravitational constant, and here is a small g, that is said to be acceleration due to gravity. We will discuss also the difference between them, because this is also a very important question, difference between capital G and small g. So first of all we will discuss now acceleration due to gravity to derive it. So as I told you, acceleration due to gravity means when a body falling under the influence of only gravitational force, the acceleration produced in the body is said to be acceleration due to gravity. Now the derivation. So for derivation, let an object of mass m, small m, and mass of Earth is taken as capital M, suppose, and radius of Earth is taken as RE, suppose. So now, according to universal law of gravitation, the gravitational force that is acting on the object is F is equals to, we know that, G into M1 mass of Earth into M2 mass of object and distance, that is the radius of Earth square. Clear? That is from the universal law of gravitation. That is the first equation. Suppose the gravitational force acting on the object is equals to G into M1 into M2 by R square. Now, according to Newton's second law, you have read in the fourth chapter, second law, force is equals to mass into acceleration. In the fourth chapter, you have read also that according to Newton's second law, force is equals to mass into acceleration. So it is also the force, but here A is replaced by small g, because here acceleration due to gravity. So therefore, F is equals to m into g. That is the second equation. Now, from both the equations, it is also force, it is also force. So that means the force will remain same. Either we can calculate by this formula or we can calculate by this formula. The force that is acting on the object is remain same. So from 1 and 2, m into g is equals to capital G into m by RE square. Both RHS will be equal. When LHS are equal, so RHS must be equal. Now from here, small m get cancelled from both sides. So that means this implies that G equals to capital G into m will be cancelled by RE square. That means acceleration due to gravity is equals to capital G, that is the universal gravitation constant, capital M, that is mass of Earth, and radius of Earth square. That means this value does not depend upon the small m mass of an object. It depends upon the universal law of gravitation constant, mass of Earth, and radius of Earth square. So that is the answer of both the question. If you have to derive small g, you can do it. And if you have to show that small g does not depend upon the mass, also you have to do the same thing. And the small g is, since it is remains constant, capital G, m is also constant, mass of Earth, but the distance, radius of Earth is not constant. But Earth is not overall a sphere. In general, the value of small g is coming 9.8 meter per second square, most of the spaces in the surface of the Earth. But at the pole, the radius of Earth is minimum. Pole में वो दबा हुआ है, तो इसलिए radius वहाँ पे कम है. तो radius जब कम है, that means g will be maximum. And at the equator, the radius is maximum. So radius maximum, so g is minimum. So at the pole, the radius minimum, so the acceleration due to gravity is maximum there. And at the equator, radius increases, so the value of small g decreases, minimum is there. So that means the value of small g is vary from place to place. On an average, we take it is 9.8 meter per second square. How it will be, we will discuss in the numerical portion, the derivation of it, 9.8 how it will come. But it will be not remains constant in all over the Earth. It will be vary from place to place. So that is about the acceleration due to gravity. Is it okay? Now in the next topic we will discuss about the mass and weight, and then after the numerical portions and the important questions. I hope is it clear all of you? If it is clear, then like this video and subscribe. Okay, and stay connected with us. Okay, thank you.